In this video, we're going to consider problems where we are solving equations involving logarithms. So let's go ahead and start with this first one. We have log of x over 2 equals 5. When it's log log, and there's no numbers right here, the base is 10. And so our first step to solving this one is to rewrite it as an exponential. We take our base 10, and we know this right here is the exponent. So we say 10 to the 5th equals x over 2. Well, I know 10 to the 5th is a 1 with 5 zeros equals x over 2. And now I simply multiply by 2, and x equals 200,000. All right, so we're going to start with this one close to the same way, but first we're going to have to add 2 and get that number on the other side. So log base 7, x over 2 minus 1 equals 2. And now our base, because there's a number written there, is 7. And remember, over here is still our exponent. So here we're going to say 7 to the 2nd equals x over 2 minus 1. Or 7 squared is 49 equals x over 2 minus 1. We add 1. 50 equals x over 2. And we multiply by 2, and we get our answer of 100. Now in these next two, we're going to be using laws of logarithms. Here we're adding 2 logs, and here we're subtracting 2 logs. When we add 2 logs, it turns into multiplication with 1 log. Whereas over here, when we subtract 2 logs, it turns into division with 1 log. So let's go back to this one. Our base is 6, our exponent is 2. So we're going to say 6 squared equals x times x minus 5. And we're going to multiply this out. So we've got 36 equals x squared minus 5x. To solve this quadratic, we're going to want the 36 on the other side. And whenever we're solving a quadratic, we check to see if we can factor first, because that's the easiest way. Otherwise, we could complete the square or use the quadratic formula. So I'm looking for factors of 36 that subtract to 5. And I'm thinking, oh yeah, 4 and 9, that'll work. So I've got, and I want it to be negative 5, so it's going to be x minus 9, x plus 4. And when I do this, I get two answers, x equals 9 and x equals negative 4. Only thing is, in my original problem, I cannot take the log of a negative number. So I can't take log of negative 4, so I have to throw out that answer. When I test 9, log of 9, that's fine, and log of 9 minus 5, or 4, that's going to be fine as well. All right, let's go finish out the problem on this side. Here's my base 6. My exponent this time is a 1, equals x over x minus 5. I can multiply both sides by x minus 5, so 6x minus 30 equals x. And let's subtract 6x, so negative 30 equals negative 5x. Divide by negative 5, and x equals 6. We should always check that we're going to have numbers we can work with. Log base 6 of 6 will work because 6 is positive. 6 minus 5 is also positive, and so I'm done with that one.